A world where you create repeatable pieces of code like Legos and you have the ability to stitch those things together. Why you think that in terms of what you are creating is fundamentally going to be helpful for the good of humanity.
You can scale your development in a healthy and predictable and good way.
I don't really know what the end goal is. I don't have a true purpose. I'm just managing the task. Hello, everybody, and welcome back to TARTLEcast. You are here with your host, Alexander McCaig, and we have a special guest today, Gilad Shoham. He's out of Tel Aviv, Israel. He is the product lead and developer for Bit.dev. And if you've never heard about it, it deals with composable programming. So if you want to consider, in layman's terms, a world where you create repeatable pieces of code like Legos and you have the ability to stitch those things together, that's what his firm's specializing in. And they've been around for about 10 years now, if I'm not mistaken, but I'm really happy to have Gilad on the show. So thank you for joining me.
Thank you for inviting me. It's really great to be here. Really
Oh,
glad
you're
to
most
be-
welcome. Yeah. And so give me a little bit about the history of BitDev and like why you wanted to even pursue this and why you think that in terms of what you are creating is fundamentally going to be helpful for the good of humanity, because I know that's a core focus for you.
Yes. So actually, it's a bit funny because the beginning of the story, like around 10 years ago, the story beginning with like how we allow or enable machine to write code. Okay, it was long time before the GPT revolution and all the LLM stuff. And one of the key stuff that you understand back then is that in order to really be able to write good code by machine, we need to change it from writing code to composing software, because composing is much easier and much more predictable task to do. So we shifted from trying to implement like a generation tools to implement and to build all the foundations on how you can split your code base into components. The term component in this context is not only front-end components. Okay, it's also for backend. It's any reusable piece of code which like clear boundaries and responsibility both for front end and back end. So we build all the foundation in order to build and help organization to split their code base. And we face a lot of challenges along the way. Like once you start creating it, you have like many challenges, like the creation overhead, like how fast can I create new components? If I want to make 2000 components, how long it take me to make one component in terms of like all the pipeline of work to create it. Then how can I search components? Right, there was no LLM back then. How can I find my components in my organization now that I have a lot of them? And how I can change component of someone else from the organization. I'm using your component. I have an issue. I have a bug. How can I fix it easily? What can I do until you approve my changes? If you at any time will even approve my changes. So we start building all the foundation in order to build components and then move from components to like composable architecture for applications as well. So building a lot of tooling, both uh, methodological tooling and technological tooling, in order to make it easier to build applications from independent features. So eventually, your application is just a composition of features. It's just a list of features. Okay, then we build a project we call Harmony. It's an open source project which allow you to easily create this composable, pluggable, extendable application where each feature connect itself to the platform, which is like just an API. And the way it works is basically by the platform team providing what we call slots or hooks um, for product team to connect themselves. So, and this works both in UI and backend. So, for example, as a user team, you can register an icon in the header for the avatar or a login button. And on the backend, as the user team, you can register a new route for the backend to do login, to do authentication, to do forget password, whatever.
I see.
And in that way, you can scale your development in a healthy and predictable and good way. And then we arrived to AI back after many years, and now we are just launching our new AI product. We call it Hope AI. Yes,
Mm.
and this is AI that is fundamentally different than other AI tools out there
How so?
because we are looking. It's back like to the original shifting how we see the AI task. What is the AI task? And the AI task for most tools is to implement on write code. And our task of the AI is to compose components. So if we are looking at like from high level overview, there are kind of like four principles that distinct how we see this differently than other tools and solution. The first is what is the base unit the AI is working with. Okay, everyone in the AI space or any developer probably heard the word token tons of times in the last few years. Okay, I'm
Yeah.
sure. Um, and the AI or LLMs are working with tokens. What is a token? Token in programming language might be some saved keywords or symbols. It might be a equal symbol or a larger than or the word if or for and stuff like this. And we want to teach the AI to see it different in a similar way as we human. Like if we both look on code on a repository, we both see lines of code as human as and AI, but we actually see it very different. If we take like for example like an analogy, if you look on a map, okay, and AI look on a map, AI will see the terrain, right, mountains, sea, whatever you see on the map, you see on you when you look on the map, you see countries, right? These countries
Yeah,
has
because
metadata.
it's a different
Yeah,
inference that humans have.
exactly. You see boundaries. Each kind of these countries you have it has meaning for you, right? You know that on Italy they eat pizza. Okay, you know that something else in some other countries there are some other properties. So we want to teach the AI to see instead of work with components, the principle we call it like composite is better than atoms. Okay, we want to work with larger or higher level of abstraction.
Yeah.
Yes, so we want the AI to work with components instead of tokens. We want the AI to work with something that have product or business meaning, that has like an API, that has a description. It's much better unit if you want to build something complicated. It's the same for everything, for music, for images, and there are many examples. Okay, if AI will see pixel on a picture, it will be hard to recognize people. But if AI knows to recognize hand and leg and face, now we can recognize people. Now we can recognize group of people.
So can I ask you something?
Sure.
Now that you have these components that are built together in a fundamentally more recognizable manner, like larger molecule chunks to like build an organism essentially, are there efficiencies for your system, right? Hope AI, for its artificial intelligence, for being able to recognize things at an accelerated rate and assemble them in a more robust fashion now that it's a more pre-built and replicable object, because now you're really leaning into the elements of machine learning at a core level to say that, oh, this is a highly repeatable thing that I know. And so in a predictive nature, I know that these two components can come together to create this higher level object that a human prompting it on the back end is saying like, I need this to occur. And so it can be like, I can do that a lot better than building the code from the ground up. Is that correct?
Yeah, exactly. That's exactly the mind shift on how you eventually both Hope and other tools build applications. But the way you build it is really matter. You can have like application working from a prompt, but it will probably won't be maintainable in the second later. Like if we try to like see, looking on the landscape of AI tooling in general, I know many people will just hear this with voice without seeing my hands. But let's imagine like a chart with like the y-axis is the code base size, okay, from small code base to large code base, okay, and large in this context is not like Google large, okay, large is like enough of like I don't know 5 developers working on a startup for a year. This is large enough for AI to be confused, okay.
Mhm.
And on the other axis, on the x-axis, you have like the complexity of the task from like a small snippet, a function, or something like this, to like a full application, a full feature, or something like this. And most AI tools today are good in one of these axes. So can either build very complicated stuff for a very small code base. For example, you can go to Bolt or Lovable or Base 44 and generate your personal website with 2 3 prompts in an hour, like vibe coding style. So you have like full task, full feature, even full application for your own personal website, which is good enough. And the other ones like Cursor and Copilot and stuff like this, they are meant to work on like larger code bases, but they mostly used, at least when they are used in large code bases, like for like autocomplete, small snippets, they are saving time of like, Googling and copy paste from Stack Overflow, which is great. Okay. It improves productivity a lot. It can help you in a lot of aspects, but you cannot really use them to what we really want to do, which is implementing real features in real companies or organizational code base.
So
Okay. And
Gilad,
yeah,
can I ask about this? So how, with the differentiation of your artificial intelligence with Hope, have you trained it under the mechanics of how the component parts, right? The composable components which you have with Bit.dev, watching how developers are bringing them together, and then the process of how a human is taking essentially building blocks, is that the base training algorithm for how Hope AI goes for its identification or assembly? Because I mean that's what it is. It's an assembly process.
yes, it is an assembly process, but we didn't train our own model, okay, which is
Okay.
sometimes surprise. Okay, we are using standard models like Sonnet, like Gemini, Llama, whatever it is.
Sure.
Um, and we just so what we do is on the RAG process, we are giving it much more useful information. The way it works, I will do like a quick recap of the principle, because we just did the first principle, and then it will connect to the process. So we said that the first principle is working with component instead of just token. The second is about the context, right? There is always the context problem, which is limited, like in size. So I need more context, but I can't, at least today. But something that's very important to think of is that more context is not always better. And many times it's even worse. So
Confuses it?
accurate context, yes, accurate context is much better than big context.
Now why is that? Can you explain why?
Yes, because eventually LLM are like kind of like statistical machines.
Mhm.
So if you give it a lot of irrelevant information, they will try to use it, and they will try to, to guess what is relevant and what is not.
Because you filled up this big context window. So it's
Yes,
assuming
yes,
like everything you gave it, I need to pay attention to it. So
yes,
you're saying if
exactly.
there's hyper precise and much more limited prompting of the context window, you have a better efficiency for how this thing statistically is going to start doing its assembly, right?
Exactly. Yes.
Got it.
Yes. So the second principle is like to give more accurate context rather than just throw everything into the machine. Okay.
Mm.
The third one is about what is in the context. So it's connecting to the second principle is like the holistic versus local. Okay. So one of the main problem with the context today with AI is they don't have access to the correct context. Okay. If you are working on your repository with Cursor, which is like, I don't know, front-end repository, and you need now to use some API from the backend. Okay,
Yeah.
but it's not on your repository; it's a different repository. Okay, so Cursor cannot access it. If you are using a design system which is in a different repository, then Cursor don't know about it. So it's always local. And what we want to do is to give the AI like holistic view, because as a human developer, if you get this task, you'll just go and look on the other repository
Yeah.
and see the or documentation or whatever you're going to see, and you're going to talk to someone from the other team, right? And we want to give the AI the similar power of seeing the big picture of how things are related. And so what we want is to give it like a full picture, and let's say like cut it down or divide it and give it only the relevant from the entire picture, give it only the relevant part, to not feed it with like
Confusing.
irrelevant stuff. Yes.
Right.
And then this is like the three principle about how AI see the code. And we as a human, we do all of this for many, many years. Okay. It's nothing new, like for human developer. And then it comes to how AI uses this stuff and how AI uses the code. Okay. And we as a human, okay, let's imagine like a developers in a company, like the best developer in your company. Okay. Everyone has someone in the company, in the team, whatever, that is really, really productive. And what is like why is so productive? So usually is really smart as a human, right? And AI is very smart, right? Everything pretty much. And he's also very familiar with the tech stack. If we're using React, he probably knows React very well. If you're using Node or Angular, he knows like the tech stack very well. For AI, this is not a problem, right? AI knows the tech stack better than any developer today, probably even more, even better than the tools creator sometimes, because he cannot forget. And then the most important part is that if this developer is there in the company from the first line of code, and he knows everything, he knows the code base very good, because then when he get a task, build a feature, build something, he's not start implementing right away, right? He's thinking about what he can reuse, who he should talk with, is what he's focusing on the import statement of the code and not on the implementation. While AI on the other side is always focused on implementation today. This leads to very, very, get the word, like for a serious problem, because AI is going to duplicate your code again and again and again,
Yeah.
right?
There's no reason for it to do it over and over because
Yes.
it only wants to implement, but it doesn't understand the why of the thing to be created and where it needs to be put without creating extra redundancies. When you have
Exactly.
these core developers, longitudinally, they have this essentially in their mind memory. Like they have a very implicit understanding of why components need to be built for an end process. But for the artificial intelligence, it lives in a totally explicit world. I know how to do this. I can write the code for this thing, but I'll rewrite it over and over just to get it put in there. But I don't really know what the end goal is. I don't have a true purpose. I'm just managing the task. And is that why there's a
Exactly.
big difference in what your hope system does? Because it's much more implicit given the way the inputs are being composed as, compared to your cursors, right? Or your co-pilots or your Claudes if you wanted to write with that.
Yes. We let developer be implicit about it while we internally being explicit about it. So what like the algorithm of so this is like the fourth and most important principle is to prioritize reuse, or reuse is better than generate. Every line of code need to be justified. If you're not paying attention to the lines of code, at some point, if with AI even more, your code base will go out of control, because if you give now today 50 developers to just write new features with AI without any limitation, do whatever you want. This code base, which is, I don't know, now is 10,000 lines of code. After a month, it will be 2 million lines of code. And at that point, you lose control. So we only always want to prioritize reuse, because it make you
Robust
code
and
base.
efficient.
Yes, it make it like grow in an healthy way, in an effective and healthy way. And the way we kind of do it is like the base algorithm. Okay, I'm simplifying, of course. Is that okay? Let's say we give AI a task. Okay, to generate a header, for example. What regular AI do? It start writing code for header, right? It's generating a header. What Hope AI is doing is okay. First thing, let's actually one line, one sentence before the algorithm, which is important. We are representing the entire code base as a graph of components. Okay, each node in the graph is a component with metadata. Okay, like the name, description, the API, of course, and some
Right.
other stuff. And also we have like relationship between, like, this component is depending on this one. It is a runtime dependency. This is a davetime dependency, and some other metadata on the components and on the relationship between them. And these components can be created from any repositories, and they are kind of like it's one graph for everything, for your entire code base. And then, so the algorithm now, what is doing is you need a header. Let's check in the graph if we have a header. Okay, maybe I can just give it to you. And we have like a kind of a semantic search layer on top of the graph to find, for example, a header might be, I don't know, navbar. And we will be able to find it if it's called navbar and you search for a header. So we are looking on the graph. If we don't find the header, what we do next is not generating now the code for header. What we do is creating a virtual graph of what we would build a header from. Okay, for example, a header. So the next step is, okay, header is built from a logo, a search box, a menu, an avatar. Okay, cool. What we do now is the same process for each one of these nodes. Let's see if we have an avatar. If we do, let's use it. If we do have,
generate, and then put
yes,
it into that component stack.
exactly. If we do and it's not exactly fit, but it's similar, let's say we have a menu, but our menu does not support, I don't know, we put in the icon next to each item and we need it for the header. Okay, let's add an API for the existing menu. So let's modify existing components. Let's build a graph for anything we don't have. And then we start generating from the bottom, from the most simple components all the way up, and always just generating the layer above later on. And before we generate all of this, we give you a view of how it looks like, okay? Because this graph is your architecture, right? And you might, like, even on building a graph, the AI can do mistakes, okay? It's still like a machine. So before even writing any lines of code, OpenAI giving you kind of like this graph. Okay, I'm going to create these components. I'm going to use this component. I'm going to modify this component. These are the relationship between them. Now let's discuss it. I want you to take this component and break it into two different components. I want you to take these two and combine them to one. Or I want you to, I see relationship between component X and Y, but I want you to go through other component, which I don't know, do a monitoring or logging.
You know what's cool about this? You talk about regenerative, and the structure of the graph, which you discuss here, is very organic. And when you get to a point of decisioning, it is a decision tree, it's a branching, and you can decide what happens with it. And the fact that you map it first before putting in all the ridiculous code generation that could happen just using a regular LLM to do your programming, you're saying, let's cut all the waste and make sure that this organism grows to the way we need it to work, and then fill in what happens to be missing in it. But it seems definitely a much more robust model, a much more natural model.
Yeah.
Was this a core part of your philosophy when you were going through actually like building this firm, right? And Bit.dev
Yes.
and Hope?
Yes. Yes. This is like the main philosophy. Like this is like the core essence of why we build hope, and to make it work in that way, which is also it like for AI is really revolutionary. But as human, we do this for many, like for a long time. Why we went back to like just put garbage of code, like tons of code? Like we already evolved from this point for many years. And also something which is like kind of a side effect, but an important one is that, you know, everyone talks about like how you get good results from AI code generation is breaking stuff into small tasks, right? Because it's much easier to build small tasks. It's same for humans, same for AI. Once we have these components like already have before we generate them, we know what are the API, like we know what are the relationship expected, and we know what the API to expect. And then when you try to implement it, you are like the LLM, like don't have like a room for much for big mistakes because it's already a very small task. Okay, implement me a button, implement me an avatar, take the button and the avatar and use them in a header component. Okay, this is kind of what is going. So the code you're getting is much better because there is no room for mistake. The
Yeah.
growth of the code is very good. And then what we do next is connect it to like the infrastructure of Bit that we built for like 10 years of like how to effectively manage components, okay? Which is like, you know, from the point AI generated code for you, you have a long process until you can really integrate it into a real code base, right? You need to review it, and then you need to run tests on it. So you need to create a pull request, and then see the CI, and then get the results, and then ask the AI, I have a test that's failing on the CI, please fix it. And then it will destroy everything probably.
Yeah.
Let's say fix it, and then another. So the feedback loop is really long from the code generation, like from the output, to really be part of your system. And once you work with components, now a lot of this is become much easier because now I need to write test for component. It's much easier
Rather
to
than
write
the entire
write a test for my entire feature. Okay, this is complicated. Now I need you to write a test for button, test for header, test for a logo, whatever. It's much easier, like human, like AI, to write documentation for each one of these components is also much easier, right? To write example, usage example, much easier. And then we connect it to our system of running, like we build a tool called Ripple CI, which is like a CI built for components. Okay, it's a CI, it's a graph-based CI. Okay, the way it works is like you change a button. Let's run the test, and then like the button pipeline. Okay, it might be test, might be linting, formatting, bundling, whatever it is. Then let's see who is using this button, like a card and some other component. Let's run their test and their pipeline with the new button, which is not released yet. Okay, it's everything is happened before releasing. Let's write, let's run their pipeline at parallel. Okay, in parallel. And then after we do this, we go layer up. Okay, level up, level up, level up from button to, I don't know, 10 applications in your system. And we run everything in parallel. And then we connect this to Hop. So Hop can run all these pipelines in parallel for all components. So it start review its own code before it's even giving you the output. Why should they see the output if it's not ready?
right. Yeah.
Yeah.
It should be
Okay. Please, yes, please run the pipeline. I'm as a platform team, I'm defining the pipeline for different type of components. I want you to run the type checking. I want you to run delinting with this configuration, whatever it is. Might be some presets. Please start running this pipeline. Make it green. And if you generate 50 components and only 3 is failing, you don't need to regenerate everything. You don't need to touch the other 47.
Leave them.
Yes, leave them. Don't destroy what you already did. Just fix these 3 components which are test failing. And then same for linting, same for formatting, same for any kind of like, CI operation. So even before giving you the output, you get like 4 or 5 review cycles by the AI itself before even giving you the output. So you get the output in a much, much, much more readiness. It's still not 100% ready. Okay, you still need to review it. You still need to check that there are no crazy stuff, but it's much faster. It's like instead of doing you like 30% of the work, now I'm doing like 80% of
It's
the
a
work.
smarter way to build.
Yeah, and then after the components, by the way, after the components level, one of one major issue with AI or even without AI is that we change code all the time. But like we said, like our code base is an organism, right? There are different parts, different there is legs, there is hands, and they are connected, right? Like maybe I have I cannot move my leg because I get injured in my back, right? They're affecting each other. You change something here, it might break something in different place. It's the same with our code and with AI code. So once you have this graph, let's say the AI like change different components, but these components are going to be part of like the bigger system. But we have the graph. So even components which are not changed by the AI, we can now use this AI to test them and to see how the components we change are going to affect components we didn't even touch.
Very cool.
And then we see if we break this component, we can ask the AI, okay, so you build the header, but now this header is breaking the about page. So either you need to fix the header or you need to fix the about page. So bring the about page into your change set and fix it. Okay, and then we do this for testing. We do this, by the way, for vulnerabilities. I can see now that if I have like an issue in like I don't know in some component, I know exactly how it affects the entire graph and how it affects which application are going to be affected by these vulnerabilities. Okay, I can see it visually, and this also give a lot of power of insights and data which can use by human and by AI. For example, do I have duplications? Like this graph, you can query it, right? It's a very powerful data. Do I have duplications? Do I have similar components which do something similar and create inconsistency? Or do I have the same component in different parts of the graph? maybe in this page I'm using the button in V2, and in another page I'm using the button V3. Okay, I have inconsistency or circular dependencies. Okay, and I can see reporting and analytics about it, and I can query the AI about it because the graph is available for the AI as a context. So I can ask the AI, if I'm changing this component, who is going to be affected?
No, it's amazing. And so what happens is you're building a more robust architecture, QA process. You're increasing the efficiencies for developers who are interacting with the artificial intelligence. So tell me, good, when we're seeing all this growth and investment into artificial intelligence, especially in the programming space, right? Everybody wants to make efficiencies there. Do you really think that it can sustain that? Or do you think it's going to require taking your philosophical route for how AI should be doing software development? Like, where do you see the main path that everybody's on right now failing? And when do you see them actually migrating over to the way you see the world and how it should be developed?
So I think like in terms of like investing money in startup, for example, like I'm also doing like angel investing in mostly in dev tools space personally, and there are different use cases. Okay, if you are some like I don't know someone is a little bit technical, like I don't know maybe a product manager, maybe a designer, and you're building some small stuff, there is a good use case. You might be able to use the existing tools, and they are doing pretty much a lot of money. But we do see that with most of this vibe coding tools, like if you are going to take a look on this on their numbers, you will see that they're kind of like the process is that they get new users. The new user is paying $20 for the first month, maybe 2 months. Building is personal stuff or small stuff, and then he cannot really keep maintaining it with this tool, so he's abandoned and stop paying. And because there are a lot of new users still in the world, still coming into the game, because the barrier is becoming lower and lower, so more people are getting into it, there is always new stream of users at this point in time. But this will not be sustainable, for my opinion, for the long run, because at some point everyone will be in the game, and if you're not doing this shift, then all the user will stop paying at some point. And also we see that there is no really organizations today that really use AI for like the organization level. Okay, they're buying I don't know Copilot or Cursor licenses for their developers, which is great because it makes them more productive. Okay, because it saves them time, save money, time to market is faster, sometimes even like a lot of time, which is great. But they are still not, utilizing the AI potential for real because they are still using it to do this small stuff instead of using it to do like much bigger and more important stuff.
Tasks.
And
Yeah.
from talking with many companies recently, since we kind of like start talking publicly about like OpenAI, I gave this a talk about OpenAI in many conferences in the past 2 3 months, and always getting feedbacks from people from organizations, from real developers, that yes, this is what we need. We need something on the organization level that really can build features in a healthy way and not killing our code base after 2 prompts.
Yeah. No, I like that. In regards to that, as we're closing up here, Gilad, where would these developers or organizations find out more about you, about BitDev, and about Hope AI? How would they go about that?
Sure. So personally, to find me, they can just go to gilad.dev. This is my personal website. Gilad is GILAD .dev. You can find them there, like all my socials, of course, LinkedIn, Twitter, whatever. So find me from there. You can see there like many podcasts and talks I gave recently, both in Hebrew and English. There is a filter on top. So feel free to follow me and reach out to me and ask questions. I really like to talk about these topics, so don't be shy about Hope AI. So as a company, we have like bit.cloud, which is bit is like bit.cloud. This is like the hosting or the company website. This is where you can find Hope and all the enterprise features like the marketing pages and the platform itself for hosting components in bit.cloud. Bit.dev, you can also find us there. There is like the kind of like more the open source website for the open source for the CLI. Bit is like we have a very big open source, like most of our core technology is open source. It's one of the largest JavaScript open source out there. I think like almost 18,000 stars on GitHub, something like this.
Wow.
And you can find us there. We have like a Slack community that you can join and talk to the team. I will see probably personally most of the messages you write there because I'm living there. So you can find me there as well. Yeah, this is like the most stuff. If you are a small startup, you're playing with OpenAI, if it didn't work well for you or you need like, I don't know, some help with this, or want to give us feedback, please do. We will welcome any feedback, good or bad, to improve, and hope you will enjoy. And we will have like great hope for it, right?
No, very, very good. I appreciate that. Thank you for letting everybody know, and thank you for coming on the show, Gilad. All these words, the wisdom, the philosophy, it all makes perfect sense. Now it's about getting the world to adopt this amazing technology that you made. So thank you for that.